Yeah, I'm going to go ahead and go to definition 1.5. I skipped an example. You're welcome to read it. If I were you, I would read all of my notes. All right, so let's do, let A and B be sets. The set R is a relation. This is now a formal set theoretic object from A to B if and only if, and then I need some help on this one. Help. I need somebody. Help. I'll never sing to you again until the next time. What's the one condition on a relation? Just has to be a subset of the cross product. What does it mean to be a subset? Every element of this is an element of that. That's it, right? So a relation, yeah, so there's some notation. If A, B is an element of R for a relation, we say, or we write, A is related to B under this relation. And then could you guess what we say if A, B is not an element of R? How we would write that? Okay. I am really excited. We just started grown-up mathematics. No offense to calculus, but a little offense to calculus. Calculus should be a little offended. Because it got so much of our time and we didn't even actually know what we were doing, right? In calculus, we didn't even prove most of the stuff. If you had teachers like mine, we didn't even prove most of the stuff that we learned in calculus. We just learned the formula, here's an example, apply it, done. And then you're like, why? And they're like, because it is a 10-week quarter. Stop asking me why. Just give me the answer, right? Yeah. This is grown up now. This is really, really exciting. All right, let's look at a very, very famous relation that saves millions of lives around this country every day. It's called the traffic control system relation. You all know this relation in your heart of hearts. All right. Unfortunately, I don't have three colors today, so I'm going to let A be, oh, I do have two colors. Okay, you don't have to pretend this is green, all right? This is green. So you're going to use your wonderful patterns of imagination. So this is going to be a green circle. You see it? Yeah. All right, you're in, right? My son and I do this imagination sum all the time. It's so much fun. He feeds me pizza that's like Play-Doh, and it's horrible. But I eat it anyways. All right, this is red. Could you guess what B is? The English word stop and the English word go. Okay, let's look at A cross B. What is the universe of possibilities when relating these two objects? Well, we could say that green lights go with the word stop. That's one option. We could also say that green lights go with the word go, gringo, right? Gringo. All right. We could say that red goes with the word stop, or the verb stop. And then we could also say that red, that's one option, goes with the verb go. Okay. In the traffic control relation, let's define a relation. What's a relation again? What's a relation? What's the definition of a relation? It's a, what's a relation, Sam? It's right in the middle. 1, 2, 3, 4 lines down. It's the only thing written. There's 1, 2. Subset. What's a subset?
All the elements are.
Just look at all the ones you could possibly do and then do what? Choose some. Choose some. Okay. In the traffic control relation, which ones do we choose?
Green, go.
Green means go. Red means stop. Is it a subset, Sam? Why? Yeah, because we chose them from the larger set, right? Okay, is this relation useful? We use it every single day, right? We associate with an object called a light a verb, right? And then we make actions based on that verb.